All right, so the first one is linear. Hopefully you're pretty familiar with a linear function. The parent looks like that. So how would you describe that? What does that look like to you?
A straight line.
A straight line. So any kind of line is going to be a linear function. Any kind of line will be linear. It can be steeper and it can be shifted. What's that? You have a change? You're in the wrong class. You don't have to. We're in the fourth period, so. Okay, and then a parent function of a line is f of x equals x. Just a plain old x. So you're going to need to know the name linear. You're going to need to know the graph is a line, and you need to know f of x equals x. Okay? Next one, absolute value. So what does that look like to you? A V, very good. Looks like a V. So any kind of V shape is going to be absolute value. It can be a skinny V. It can be an upside down V. Any V shape is going to be an absolute value. A good way to remember that, value V. All right, and then the parent function of an absolute value. You're going to have these bars. They're called absolute value bars. We'll talk more about them when we get to that unit. But try to make them a little bit longer so they don't look like ones. And then with an X there in the middle. All right, absolute value. All right, next one, quadratic. What does that look like? A U. A U. You can also think it looks like a smiley face or a sad face. So for the children, the way it can be shifted, you could have it shifted up, and you could, like I said, have a frowny face. You could have it flipped. Any kind of U shape will be a quadratic function. Anybody know the parent function of a quadratic? From Algebra 1?
Isn't it like a plus? No.
It's got an exponent.
X squared?
Yes, very good. X squared. Quadratics are x squared. All right, we good? Can I move on? Okay. Cubic. Cubic function looks like this. Can you see it? All right, so what does it look like to you?
Horizontal. A road.
Okay, a road, race car track,
Snake road.
road, snake. What else? Some people said hill. What is it? Huh?
River.
A river. Okay, a river. Squiggle.
Squiggles.
All right. So the parent function of a cubic. Any guesses?
X cubed.
Yeah, x cubed. And just like all the other ones, your cubic function can be shifted. It can curve the other way. But I want you to note that your arrows are going down and up.
So it can never be side to side.
Yeah, side to side is different. Arrow's going down and up. All right, ready? Okay, turn it over. All right. Radicals. Radicals are next. Okay, radicals I split up into two graphs because there are two special kinds of radicals. We can have even radicals and we can have odd radicals. And they are going to give us slightly different graphs. What's up?
Does that record your voice also?
Yes, it does.
Ooh.
Yeah. So your class is the one that's recorded and will be on YouTube. Woohoo! So, I don't know. First time I've done it, so we'll see how it goes. All right, so the parent function is going to look like that. Okay, so you might have seen this little box symbol, right? It's like a square root. All right, a radical is any kind of root, though. It can be a square root, a cube root, a fourth root, an eighth root. It can be any root. Any root. All right, and depending on whether this n is even or odd will depend on what kind of graph you get. So if this n is even, then your graph is going to stop and then be an arrow. Very important. The even graphs are at a point. They end at a point and then an arrow. They're the only graphs that end at a point. All the other graphs have arrows both ways, except for the even radicals. The odd ones, you're going to have the arrow, but it's going to go both ways. You're going to have an arrow to the right and to the left. It looks really similar to cubic, but if you notice, your arrows are going to the right and left, not up and down. All right, so that's kind of the difference. So the way that I always remember radicals when it says what does it look like, I just remember them. They're arrows to the right or left. All right, so because all the other ones, the quadratics go up or down, the cubics go up or down, the radicals are going right or left. All right, it's an arrow to the right and then a curvy arrow to the left. That's kind of how you can tell them apart from the other stuff. All right, for the children, the transformations, your point can be anywhere. I mean, it can be like over here. Your arrow can be upside down. It can be shifted all over the place. Your arrow can also go in the other direction. You don't normally see it that way, but it can. And then for the odd one, you can have that flipped around too. Ooh, that was ugly. Alright, so you can have that squiggle flipped as well and shift it all around. Any questions on radicals?
Will you ever use them in your video?
Maybe.
Could it get like wider? So like for example, the odd
Like,
longer.
mhm.
Keep on going. Oh,
Yep. But still, your arrow will still go to the, like it would look. Like that. Like your arrow's still going to the right though, and to the left. All right. Rational. All right, the next three graphs, we have rational, logarithmic, and exponential. All three of these graphs have something called an asymptote. Y'all heard that word before?
Yeah.
Good. So the rest of these graphs do what? I've always heard of asymptote. I mean, tomato, tomato. You can call them asymptotes if you want. The rest of these three graphs are going to have asymptotes. An asymptote is a line you can't cross. It's like a boundary, right? It's a boundary for your graph. And they're going to be really important helping us distinguish these last three graphs, because these last three graphs all look really similar. Really similar. They're all going to have these little things. I call them bananas. To me, they look like bananas, and so that's what I call them. So when it says what does it look like to you? You can just put bananas on all of them because they all look like bananas. So the asymptote is going to help us distinguish between whether it's a rational, exponential, or a logarithmic. All right, so rationals are going to have two asymptotes. On the parent function, they're on your axes. If you have two asymptotes, you're going to have a rational function. And then your bananas are going to get really, really close to those asymptotes, but not ever touch them. So you see they kind of look like bananas. They're yellow. So they get real close to those dotted lines, but don't ever cross or touch. They're like your boundaries. And when we get into these functions, we're going to talk more about asymptotes and stuff. Okay, the parent function, f of x, equals, it is a fraction 1 over x. It's a fraction 1 over x. X has to be in the bottom of your fraction for it to be rational. That's very important. X has to be in the bottom of the fraction. And just like everything else, we can shift this graph and these asymptotes all over the place. They can go a little bit higher. They can go in the other two quadrants. exponentials. All right, two more. Two more. All right, the next one we have logarithmic. We shorten that and say log because no one wants to say logarithmic over and over again. So a log function is going to have a vertical asymptote. And it looks kind of like that. So logs have vertical asymptotes. Kind of the way I remember that, logs have an L. L is vertical asymptote. I don't know, it's a little bit of a stretch, but. Okay, that vertical asymptote, it can be shifted to the left. It can be shifted to the right. Your banana can kind of get flipped upside down. We'll talk more about what that means when we do logs. But if you have a vertical asymptote, it is a log. And the parent is f of x equals log base b of x. That's the way you read it. This little number down here, it's your base. So log base b of x.
Base B.
And b can be any number. So log base b of x. All right, last one, exponential. If logs have vertical asymptotes, exponentials have horizontal asymptotes. All right. So exponentials, they're going to have the horizontal asymptote, still the banana shape, so you see how they can get confusing. They all look very similar. And just like the logs, you can shift the exponential function all around, and it can curve different ways too. As long as it's a horizontal asymptote, then it is exponential. Okay, and then the last thing, the parent function, f of x, is going to be the base raised to the x power. X is in the exponent. That's why it's exponential. See what they did there? Exponential, x in the exponent. If x is in the exponent, you have an exponential function. And then base could be any number.